All right, is the grand finale for the week. We are going to be looking at 6.3, and we're going to be doing solving and graphing multi-step inequalities. So this is going to put together things we learned when we were solving equations with what we've been learning this week. So when you see problems that have just more than one step, meaning up until now you've had to just add a number, or just subtract, or just multiply, or just divide. But now you're going to have to go back to when we were solving equations and possibly do several steps, which is why they're called multi-step inequalities. So things you want to watch for are the same as back when we were doing equations. You want to watch for opportunities where you might have to distribute. And a big key factor in knowing to distribute is that you'll see parentheses. So if you have a 2 out in front of an x minus 4 in your equation, you would have to, or you would want to distribute that and then say, oh, I'm going to rewrite that as 2x minus 8 potentially. So then you would go into the next phase from there. That won't happen every time, but it's something that can happen, and you want to be watching for that. Another thing that you would watch for, and we did this back when we were solving, but we haven't done it for a while, is you want to watch and see if you need to combine like terms. So if in your problem you have a 3x plus an x, you would want to rewrite those together as 4x and then take that on into the next phase of your solving. At that point, you're going to be getting to the things we've been working on this week. So when you have maybe both some multiplication and some addition, what you want to do first is you want to get that x alone. Typically that means that you're going to move numbers that are added or subtracted into the problem. They're going to be the most detached from the variable, and I'll show you what I mean in the examples. And then the last one is going to be to separate the number that's attached to the x, and you're going to separate that last number by using multiplication or division on that very last step to get the x alone. And I'm going to put the x in little quotes because it doesn't have to be an x. Now that's going to be the spot where you've got to really be careful, because keep in mind that little tricky thing that we learned. If you're going to be using multiplication or division in this last step, you want to be watching for multiplying or dividing by a negative number, because that's going to require you to flip your symbol. So that's going to be just, again, something you have to catch as you go through the problems. So I'm going to go ahead and do what it says. My two verbs this whole week: solve and graph, solve and graph. So in this first example, there's a couple things I can do, but looking at my list, I can see that I have parentheses. So I'm going to go ahead and distribute. If I distribute this, I'll have 2 times x minus 2 times 1. So when I look at my list, I did distribute, and the parentheses were a good heads up that I might have to do that. Combine like terms means that I would have x written in a couple different spots in my problem, but I don't. So I'm going to move on to moving numbers that are added or subtracted in, because these two right here, the 2 and the x, they're attached by multiplication, so they're pretty close, which means this is going to be the thing that moves out of there first. And to get rid of a negative 2 or a minus 2, I'll need to use adding, and I'll do that to the other side as well. So at this point, and I'm just going to put my work up here, I'll have a 2x left on the left side, then my less than, and then 6 plus 2 puts an 8 on the right. Now I'm on my last step. Use multiplying or dividing to get the x alone. Well, to get that x alone, I'll need to divide by 2. I'm dividing by a positive number, and so I do not have to worry about flipping the symbol or doing anything else. I just go ahead and divide by 2. So my solution when it says to solve is that x is less than 4. So when I go to graph it, 1, 2, 3, 4 is right here. It is strictly less than, not or equal to. So I'm going to put a big old circle saying, hey, I'm going to start at 4, but I'm not actually using or including the 4. And then a less than symbol is going to shoot off here to the left saying, hey, all these numbers are less than 4. Awesome. Let's take a look at the second example. I don't have parentheses, so I won't be distributing. But I do see that I have some like terms, and they're on the same side of the tracks. So I need to put them together. So negative 3x plus 2x is going to give me negative 1x less than or equal to negative 8. So I did my combining like terms. Normally I would move any numbers that are added or subtracted into this problem, but I don't have any. So I skipped that step. All I'm trying to do now is get the x alone, which means I need to separate it from that negative 1 that it's currently multiplied by. So to separate multiplication, I'll need to divide, but be careful, you guys, because here you've got that little red flag flying because you are dividing by negative 1. So these will cancel out and be positive. So will these. But you need to flip the symbol because you were in this situation. Watch for multiplying or dividing by a negative and then flip. We divided by negative 1. So in the end, my solution to this is that x is greater than 8. Oh, I'm sorry, that'll be greater than or equal to because I flip it around, but I don't lose the or equal to. So when I go to graph this one, I'm going to be at 1, 2, 3, 4, 5, 6, 7, 8. Greater than or equal means I'm going to be including that 8. And then I want numbers greater than that. So I'm going off to the right from 8. Alrighty. What about here? I don't have parentheses, so I don't need to distribute. I don't have x's all throughout the problem, so I don't have to do combining. So I really can start on my third thing. I need to keep the 3x together until the very end. So to get rid of my plus 5, I use a minus 5. Now, I'm just subtracting. I'm not dividing, so I don't do any flipping or anything. I've got my 3x. I keep my greater than or equal to. And then here you've got a negative 7 and a negative 5. You're basically taking negative 7 and adding it to negative 5. So that's going to give you a negative 12. The negatives do not cancel because you're not multiplying. You're just saying, hey, take away 7, then take away 5 more. So you would have taken away 12. Then my last step is to get the x alone, which is currently multiplied by 3. So I'll go ahead and divide it by 3. So I have x greater than or equal to negative 4. Now don't think that I forgot to flip the symbol because I'm not dividing by a negative. I divided by positive 3. Just because you have a negative in the problem doesn't mean you flip the symbol. You have to be dividing by or multiplying by a negative number. And I wasn't. I just got a negative answer. So x is going to be greater than or equal to negative 4. So if this is 0, 1, 2, 3, 4 to the left is my starting location. Greater than or equal to means that it's going to include that negative 4. So I color that thing in. And then greater means numbers that are bigger. So off to the right. And hopefully you're getting pretty good at the graphing after the practice earlier in the week. All right. So my last example, no parentheses, so I don't have to distribute. I do not have any x's like spread throughout the problem, so I don't have to do any combining of like terms. So what I am going to look at is these two are connected really closely. So the first thing I'm going to get rid of is any numbers that were added or subtracted in. So that would be my 3. To get rid of a plus 3, I use a minus 3 on both sides. This is gone. So now I have x divided by negative 2 is greater than, and taking 6 plus negative 3 brings it down to a 3. because it's basically 6 take away 3. All right, now to get the x alone, it's divided by -2. So to get rid of division, I need to multiply by -2. And I do that on both sides. And I remind myself, hey, I just am multiplying by a negative. So I'm going to need to flip the symbol in this problem because I'm multiplying by a negative. Here, the 2's and the negatives cancel, leaving me with x. I flip my symbol because the alligator's like, now the bigger stuff's over here, so I'm going to flip around. 3 times -2 is a -6. There is my solution. So I find -1, 2, 3, 4, 5, 6. It is x less than, strictly less than, so I'm not going to color it in because this -6 isn't included. But I want x's less than or lower than, meaning off to the left. So that is my final example. So keep these handy. Watch any parts you need to. When you come across a problem that's tricky, refer back to your notes. And have a fantastic day. Bye, guys.